Chill water temperature control analysis. In these slides, I'm not pasting all of the text from the lesson into these slides. I'm just looking at the lesson and then like reading through it and then saying, oh, I quite like that part. I paste it into here and I talk about it. So don't just watch these videos and think that lesson's over. You've got to watch the video and then go into the lesson and read all the text in the lesson in the learning management system so that you get the big picture. I'm just picking this one part out. Many engineers will reset the chill water temperature set point referencing the outside air temperature or the average or maximum position of the cooling valves. My opinion is that the outside air temperature and the cooling valve positions are not a good indication of system load. So this discussion is sort of, I think why I got this here was that I'm going to give you an example of where we optimize we optimize something, we develop a smarter control strategy, and we download it. It doesn't work at all. So in the previous slides or previous lessons, I've talked about this idea that you can't just download the program and leave it. You've got to tune it, right? So that was a discussion where you've got the right control strategy, but you need the right parameters for it to work. Right? This is a discussion now where you got the wrong control strategy. You've optimized something, you've gotten paid to optimize something, and the control strategy is wrong, in my opinion at least. So let's unpack this one for a moment. So the example I want to talk through here is in Australia, it's very common for BMS companies to reset the chill water temperature set point on cooling valve positions. And the idea here is that if the air handling unit and fan coil and chill beam, if the cooling valves are all fully open, it means there's a high demand. It's probably hot outside. The building is very occupied. We're in full cooling. If the cooling valves are fully open, then we need lots of chilled water, lots of cooling. So the idea is if all the chilled water valves are mostly open, then we reset the chill water temperature set point down to 6 degrees Celsius, the design, and we give them full cooling. And then if the AHU cooling valves are closing off, so there's less demand, so all the valves are now say 50% open, we give them a little bit, 8 degrees Celsius of water. And if all the cooling valves are mostly closed, the average cooling valve position is say, 15%, 10%, 20%, then obviously the AHUs don't require much cooling, so we raise the temperature set point up a bit more, right? So this is the idea. This is a very common control strategy in Australia, which in my opinion doesn't work. And let me explain to you why. In the old days, 20 years ago, we didn't reset the chill water pressure set point. We didn't do that. So the chill water pressure set point was fixed at say 200 kPa, 200 kilopascals. It was fixed. The pressure in the system didn't change. Okay. In those days, the position of the cooling valve was a true indication of the load. So if the cooling valves were mostly open, it's a warm day, there's a high load. If the cooling valves were mostly closed, it wasn't a high load, it wasn't very hot outside, there wasn't a lot of people in the building, we need less cooling. However, when we decided to reset the chill water pressure set point down, everything changed. So now what we do is we look at the cooling valve positions, and if the cooling valves are mostly open, we reset the pressure set point up to put more pressure into the system. If the cooling valves are mostly closed, we don't need much pressure and we reduce the pressure set point down. So when you look at a chill water system with a chill water system pressure set point reset, you will usually see that the valves stay in the same place. So you might have like the control strategy might say, reset the chill water pressure set point up and down to maintain the most open or the second most open or the fifth most open cooling valve at 90%. That's the control strategy. So if you've got the third highest cooling valve and you look at all the cooling valves, the third one is going to be on the set point, 90% open position. So for a lot of you, you know that, that's fine. If you don't know that, you might need to think about it a bit more. But what it meant was that when we started changing the system pressure set point, it meant that the cooling valve positions were no longer an indication of the load. All right. So on a hot day, the pressure set could be up at 250 kPa and the valves are sitting over here. And then on a cooler day, the pressure set point is 150 kPa. The valve is still sitting here. So if you're resetting the chill water, say you don't understand, let's pause for a second. Let's assume that's a bit confusing for you. You haven't heard that before. Just know this. If you are resetting the chill water pressure set point up and down on something, if you're doing that, then it means that the cooling valve positions are not a true indication of what the load is. Just believe me on that. So if the cooling valve positions are not an indication of the load because we're changing the pressure, how can you use the cooling valves to reset the chill water temperature set point? You can't do that. In the old days with the fixed pressure set point, 250 kPa fixed, the cooling valves were an indication of the load and you could use them to reset the chill water temperature set point. But we always reset the chill water system pressure set point. We always do that. So we can't use the cooling valve. So there are hundreds and hundreds of builds in Australia where the chill water temperature reset strategy completely doesn't work. And it's likely there's thousands and thousands of buildings in the world, thousands, where we're resetting like this, it's not working. So what I do is with my control strategy is I reset the chill water temperature set point, 6, 7, 8, on the flow rate through the chiller evaporator or the pressure across the chiller's evaporator. So if the system needs lots of water and the pumps are pumping hard to support that, you will see lots of water going through the evaporator, lots of water. Drop the chill water temperature set point to support that. If for whatever reason the pumps are slowing down, because we don't need much water out there, the pumps are slowing down, and you have less water through the chiller evaporator, the load must be low. Let's increase our chill water temperature set point to support that. Now, this is actually a discussion about trends and not control strategies. That's a bit deep-ish, that discussion. The point I'm trying to make here simply is this. Like two things. It's actually supporting the previous lesson, which says that don't assume that an optimized control strategy saves energy. Because in the previous lesson, it didn't save energy. You didn't tweak the parameters properly. And in this lesson, I'm saying that many optimized control strategies that we are deploying worldwide actually don't work. Just no one realizes they don't work. And this is one example. And I can tell you right now, if we spent 8 hours on this, we could go through many chill water systems, AHUs, fan coils, VAVs, everything. Even things like VAVs and fan coils, we're doing the wrong thing. So understand that. An optimized control strategy doesn't always save energy. You didn't tune it properly. An optimized control strategy doesn't always save energy because it's wrong.